In pretty much any death investigation, there's one question that always comes first, the one that kicks the whole thing off. When did it happen?
I mean, we've all seen it on TV a million times, right? The medical examiner walks in, takes a quick look, and boom, time of death, 11:42 p.m. But how real is that? Can they actually do that?
Well, the truth is, no, they can't. It's just not that simple. But what they can do is actually way more fascinating. They become translators, reading the clues left behind by the body's own natural clock.
Okay, so let's dive into this. The first and most critical clue, the one they turn to right away, is something we can all understand: body temperature.
And this isn't just one of the clues. It is the single most common, most reliable method they have, especially within that crucial first 24-hour window.
The science behind it has a name, of course. It's called algor mortis, and really it's just a technical way of saying that a body cools down after death at a fairly predictable rate. So if you can measure that temperature drop, you can basically hit rewind to estimate when it all started.
But it's not a perfect science. A body doesn't cool down in a vacuum, you know? There are other factors at play. So what do you think is the biggest thing that could speed up or slow down that cooling process?
By far, the single biggest factor is the ambient temperature, just a temperature of the room or the air around the body. It makes sense, right? A body in a cold room will cool down way faster than one in a warm one. Now, other things like body weight and clothing, they definitely play a part, but the environment, that's the real game changer.
So temperature gives us our first best reading. But as that's happening, another well-known process is starting to kick in, and it offers its own set of clues.
And I'm talking about rigor mortis, that temporary stiffening of the muscles. Because it follows a pretty predictable schedule, it acts as another marker on that forensic clock.
This progression gives investigators a rough but really useful window. It usually starts about 3 to 6 hours after death, beginning in the smaller muscles, like in your jaw and eyelids. From there, it spreads, peaks when the body is fully stiff, and then eventually it goes away completely, usually within 24 to 48 hours.
But here's the thing you absolutely have to remember. While rigor mortis is a valuable tool, it's much more easily affected by outside factors, things like the temperature or the person's physical condition before death. That makes it a helpful secondary clue, for sure, but it's generally not as precise as that initial body temp reading.
An investigator is never, ever going to hang their hat on just one piece of evidence. It's all about layering these different observations together to build the strongest possible timeline.
And besides temperature and rigor, they've got other tools in the kit. There's livor mortis, that's the pooling of blood. It's fantastic for telling if a body was moved, but it's less precise for timing. Then you have forensic entomology. Yep, the study of insects, which can be incredibly accurate, especially after that first day has passed. And there's even new stuff, like studying DNA degradation, but that's still pretty experimental for field use.
So what does this all boil down to? It's about taking all these different clocks, the temperature clock, the rigor clock, and everything else, and synchronizing them to create one single cohesive story.
So let's just quickly recap what we've learned here. Body temperature is the gold standard, especially early on. Rigor mortis adds another crucial layer to the timeline. The environment can change everything. And maybe the most important takeaway is this: the final result is always a calculated estimate, never an exact down-to-the-minute time.
The professional term for what they're doing is establishing a postmortem interval, or PMI. The goal isn't to find one magic number. It's to create a credible, scientifically defensible range of time, like saying death occurred sometime between 10 p.m. and 2 a.m., that all the evidence points to.
So you see, it's a science built on careful observation and interpretation, which really leaves us with a final, pretty heavy question. If everybody truly does tell a story, what are the consequences when a single one of these clues is misread and the entire timeline of that story gets thrown off?